All right, this lesson we're going to look at solving quadratic equations. Again, quadratic meaning we have a second degree, or my largest power again is x squared, or my biggest term is x squared. One of the things about it is when we talk about higher order equations, we talk about the degree. And what the degree tells us is how many zeros, but right now I'm going to talk about is number of solutions we should get. Okay, so with our quadratic equations, every time we should get two solutions because we're dealing with a second degree equation. Excuse me. If you think back, excuse me again, first semester you did a piece where you factored these down, and so you had two linear pieces, and so you think linear x to the first times another linear x to the first gave you the x squared. That's why we're going to get our two solutions, because we'd have two individual linear equations that we would solve. So what I'm going to do though again is I want to show you one method that you can use every time. And so we're going to go ahead and every time get my equation into standard form. Okay. So if it isn't in standard form, number one, we want to put it in standard form. Again, that being ax squared plus bx plus c. Okay, in descending order, all equal to 0. So in the equation that I have up here, the x squared plus 3x minus 54 equals 0, that's all good. Okay. Again, I want to identify A, B, and C. It's very important that I understand which one's which before I start plugging numbers into an equation into the formula. Okay, so in this case, A is 1, B is 3, C is negative 54. All right. Another reason, and we'll see this example in a little bit, if you remember when we graph, sometimes we're missing a term. And so rather than make the error trying to pull it out or as we go and putting it in the wrong place, this way we can see it. So now I'm going to plug them into my quadratic formula. Okay, now a couple things again. I want to read this as the opposite of B, okay? Because I don't want to say negative B, because when I say negative B, sometimes what happens is we think that term has to be negative. So we want to read it as the opposite. When we square things, they're always positive, okay? Negative times negative becomes a positive. That's another common place that we can make a mistake. So here I go. X equals, and again, write this whole thing down. Don't just try and shorthand stuff. Just follow away with it. Opposite of B. There's my B. It's 3, so the opposite's negative 3. Plus or minus. Okay. Now, when I square this, I try and do this in my head, or like I've said, put a list of perfect squares through 20 squared on your sheet so you can do this. And don't even worry about the sign. So 3 squared, even if we're negative, I'd look at 3 squared, that's 9. Minus 4, it's always going to be there, times my A, even though it's a 1, write it, times my C, negative 54. All over 2 times A, and a lot of times I'm going to do that multiplication as well. All right, now we're going to simplify it. And so what I need you to do first is take care of this part that's inside my radical. Okay, and my suggestion is always to type that into your calculator. Okay, because then you'll make fewer mistakes. So again, 9 minus, let me get this stuff out of there, 9 minus 4 times 1 times negative 54 gives me 225. So I'm going to take this next step and I'm going to just rewrite it. Okay, I'm going to take multiple steps here. I'm not just going to try and do everything at once. Then I'm going to look at 225. Is it a perfect square? If it is a perfect square, okay, we'll replace it. If not, we'll simplify it. So it is a perfect square. It's 15. Now, what I want to do again when we get a situation where I have a perfect square is I want to break it into my two parts. One where I add the two things in the numerator, and then one when I subtract it. And again, when we simplify these, we simplify my numerator, getting ahead of myself, and then we divide. Simplify your numerator, then we divide. And there's my two solutions. All right, so if we look at another example, okay, it's in standard form. So A in this case is 2, B negative 5, C, negative 3. Again, we take our sign with. Plugging it in. X equals opposite of B. Opposite of negative 5 is positive 5. Okay. Plus and minus. That's what's helping us get our two solutions. Now, like I said, when I do my B squared, I don't worry about the sign, because again, I need to remember that it's going to be positive no matter what. So I'm just going to take the 5 squared minus my 4 times my A times my C, again, making sure I bring the signs with. 2 times A, 2 times 2, I'm going to do that in my head as well. Okay. So again, where I'm going to go is I'm going to type what's in the radical underneath the square root sign into my calculator. And then I'll see that what I'm going to get is 49. So now I have 5 plus or minus the square root of 49, all divided by 4. And again, square root of 49 is 7, so I get that perfect square. Okay. So when I do that, I want to write it out twice. Once when I'm adding the numerator pieces, once when I'm subtracting it. And then divide by 4. So 12 divided by 4, one of my solutions is 3. Negative 2 over 4, and again, we always want to try and simplify, and like I've said, if you're not sure what it simplifies down to, okay, use that calculator, use the ability the calculator has to change it back to a fraction. All right, so here's one of the reasons why we want to identify A, B, and C. Okay. You're missing your C value here. Okay. And so I've identified A is 4, B negative 18, C at 0. Okay. So now what I've done with that, I'd like you to pause the video. Okay. And what I want you to do is plug the numbers into the quadratic formula. Once you've done that, come back, and then we'll pause again and have you solve it. So take a pause, plug the numbers in. All right, so here's where we should be again. Opposite of B was 18 because B was negative 18 now. 18 squared again. If you have that list, okay, I can look at 18 squared and write it as 324, and again, it's not going to be negative, it's going to be a positive, and so on and so forth. So now, go through, simplify this, okay, and see where you get. So pause the video again. All right, so if you notice what happened in this case, this whole piece right here, okay, even if you typed it in your calculator, you might recognize that 4 times 4 times 4 ends up going to 0. Okay, which is fine. And then so we're left to the 324, square root was 18, break it into my two solutions. When I add the 18s, when I subtract the 18s. Okay. Now again, simplify your fraction, and yes, it's fine to get a solution of 0. Some of you may recognize that what we're actually doing here is you can factor out the common term. And then one of the things that we do is set each factor equal to 0. Okay. If you recognize that, that's great. But again, I'm working on one method. All right, so let's do a similar situation with this one for a practice. But again, number 1, standard form. What's happening here is I'm missing my x term this time. Okay. So what I want to do again is add in this 0x so that I have A being 9 because A is always with my x squared. I have B being 0 because it's always with my x, and I have C, my constant, at negative 16. All right, pause and plug in. All right, so this time something different is going to happen because what I'm seeing is my B is 0. So opposite of 0 is still 0. 0 squared is 0. Okay. So interesting thing that's going to happen is I'm going to have 0 plus or minus, and then again I'm going to go type in all that stuff. So 0 minus 4 times 9 times negative 16. Okay. It's going to give me 576. And the square root then of 576 is 24. So when I break it into my two pieces here, I got 0 plus 24, and then I got 0 minus 24. 24 over 18. Simplify that down to 4/3. Negative 24 over 18. Negative 4/3. Okay. This is a case where I'm getting opposites. And if some of you recognize, the reason is because I have a difference of squares, which I could factor like that as well. Okay. All right. What I'm going to look at with this example, I'm going to go and write everything down. It's more to when we get to my solution. So what I'd like you to do is just pause it and see if you can get to a point where I don't have that perfect square. Okay, just go ahead and give that a try. All right, so hopefully you're to this point. Okay, again, I'm not going to go through that more to deal with, you know, where I'm at right now with that. So when I look at the square root of 916, if I go into my calculator and try and figure out what it is, as soon as I see that it's not a integer value, okay, a whole number value, it's not a perfect square, what I need to do is break it down. So what I need to do is go over here and break down the 916, looking for things that I can pull out. And like I've said, you can always take a 2 out of an even number. Okay, so we get 458. Meaning, again, still even, so I can take out another 2. 229. Okay, but now I've gotten a pair. Now, 229. Do we know anything that goes into it? Looking at my rules, okay, that I suggested. 2. Okay, even. This one's not even. 5 doesn't end in 0 or 5. 3, if I add up my digits, 2 plus 2 plus 9, it's going to give me 13. It's not divisible by 3. So according to the ones I've given you, it's okay to stop here. Okay. So what I have then is 2 plus or minus. When I simplified the square root of 916, I got a pair of 2s, so I took the 2 out. 229 is by itself, so we'll leave it in, all over 24. Now, remember, if I simplify, okay, what has to happen is I have to be able to divide the same thing out of all 3 of those parts, which I can. I can divide a 2 out of each of those. Okay. So x equals 1, doesn't disappear. Okay, we have to think about 2 divided by 2. And that's why I've suggested writing this one in as well, so we see that there is a number piece there. And there's my solution, which is okay. And again, this is what we talk about as an irrational number because I don't have that perfect square. In this case, we'll leave my solution look like this because the 1 plus the square root of 229 divided by 12 is one of my solutions, and the 1 minus the square root of 229 is also 12. All right, for time issues, what I've done is I've already set up most of this last example. So again, x squared minus x plus 17 equals 0. So again, identified a, b, and c, plugged everything in. What happened, excuse me, when I went in and typed that stuff in the radical, the 1 minus 4 times 17, I got a negative value. Okay. So right away, because of the negative value in the radical, we know we're dealing with imaginary numbers. Okay. So what I have then again is simplify this radical. Remember, the negative comes out as an I. And then we should break the 67 down, which with our rules we can't, so there would be my solution. Okay. But again, very important you remember the I because of the fact that it is an imaginary. All right, good luck.